Welcome, everyone. Imagine for a second that you are sitting on the grid at a Formula One race. The lights go out, the engines roar, and from that exact millisecond, every single fraction of time dictates whether you end up on the podium or crash out in the first corner. That is exactly what sitting your Cambridge computer science exam feels like. I am so excited you're here today because we are treating this explainer like a high-stakes pit stop. We're looking at a massive topic, compressing text files, bitmap images, vector graphics, and sound files. Whether you are tackling syllabus code 0417, 0478, 0983, 0984, 2210, or especially the AS and A-level 9618, the strategy remains the same. Every mark is a second shaved off your lap time. If you want a real strategic advantage, you are in exactly the right place. We are going to break down the examiner mindset, apply pit crew precision to your exam timing, and level up your strategy so you stop leaving easy marks on the table.
Okay, let's dive right into the challenge by revealing the massive stakes up front. Look at that number, 15%. This specific topic, data compression across text, images, and sound, accounts for approximately 15% of your total marks in Paper 2. That is the literal difference between a devastatingly average grade and a top-tier result. Now, let me introduce you to two typical students who tackled a brutal past paper question on this very topic. Let's call them Alex and Sam. Alex is the overloader. Alex memorized every single textbook definition, but dumps raw computer science facts onto the page with zero analysis. It's like bringing a tractor to an F1 race. Lots of power, completely useless on the track. Then we have Sam. Sam rushes. Sam completely misses the command word requirements, sprinting past the finish line without actually answering the question asked. When you look at their papers side by side, it is a sea of red pen marks. They both crashed out, and today we are going to make sure you don't make their exact mistakes.
To secure that 15%, here is our pit wall strategy for today. 1. Core principles, where we fix the foundation. 2. Procedural framework, your step-by-step race plan. 3. The method mark strategy, which is literally the safety halo that will save your grade. 4. Top examiner warnings, where we look at the telemetry of why students crash. And 5. Evaluative exam strategy, the ultimate key to unlocking the highest possible grade band.
Let's move straight into Act 2, starting with our first section, Core Principles. The golden rule here is depth over breadth. You need to decode the command words that Cambridge throws at you. If the exam says evaluate, it doesn't want you to just describe. This right here is why Alex failed. Alex went for superficial breadth, but examiners are explicitly looking for analytical depth. Knowing the definition of run-length encoding or Huffman coding isn't enough. They want to see that you truly understand how compressing a high-resolution bitmap fundamentally differs mathematically from a vector graphic. To do this, top students use the Peel framework. Point, evidence, explanation, link. You make your point about lossy compression, you provide evidence like sample rate reduction, you explain the impact on file size, and you link it back to the specific exam scenario. Now, before we look at how to perfectly apply Peel to an actual question, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It's the best way to keep your exam strategy fine-tuned.
Now, let's talk about Sam's mistake. Remember how Sam rushed? Notice this exact phrasing drawn directly from the syllabus, transferable to unfamiliar contexts. Sam rushed and gave a generic answer about compressing an MP3, but the question was about compressing telemetry data from a deep space satellite. You have to take the core concepts of data representation and adapt them on the fly. You might face a weirdly specific audio file format or a proprietary vector image scenario. If you just recite textbook definitions without connecting them to that unfamiliar context, the examiner is going to penalize you heavily. You have to look at the data in front of you and adapt your Peel framework to match the specific track conditions of that question.
So, the crucial takeaway for our core principles is that your answers must hit these three distinct cognitive domains. Think of them as the aerodynamics, the engine, and the tires of your F1 car. You prove your knowledge and understanding by defining the concepts. That's the engine. You hit application by using the specific numbers provided in the exam scenario. That's putting the power to the tires. And you reach analysis by evaluating why, for instance, a lossy compression algorithm might completely corrupt a text file full of code, but work perfectly fine for a background music track. You need all three to win.
Which brings us to Act 3, the transformation, Section 2 on our agenda, the procedural framework. This is where we systematize your approach and bring Alex and Sam into the pit lane to fix those red pen marks.
If you want top marks, systematically map out your exam answers using this precise 4-step sequence. This is your computer science success blueprint. Step 1.
Identify the key elements. Are we dealing with sample rate and bit depth for a sound file, or resolution and color depth for a bitmap? Step 2, apply the relevant principles and formulas. Step 3, execute your analysis with clear working. And step 4, verify if your results actually make logical sense. All right, we are going to do a live transformation. I want you to mentally rewrite Alex's flawed fact-dump answer using these 4 steps. I'm putting 60 seconds on the visual timer in your head right now. Go. Think about how you would extract the exact color depth. Think about how you would apply the formula. Formulate your Peel paragraph. 30 seconds left. Structure that explanation. 10 seconds, link it back to the prompt. And time.
Let's look at the result of that transformation. Those red pen marks are now turning into green check marks. Why? Because in practice, following that blueprint means your data interpretation skills are razor sharp. You confidently extracted the raw binary data from the question prompt. You didn't just guess, you actively performed the file size calculations. And finally, you synthesized those numbers into evidence-based conclusions. You didn't just write, the file is 4 megabytes, you wrote, because the file is 4 megabytes, it exceeds the email attachment limit, therefore a lossy compression algorithm must be applied to reduce the color depth. That is how you secure the marks.
Okay, we are moving into Act 4, Section 3 of our agenda, the Method Mark Strategy. This is the interactive workshop portion of our explainer. But stop scrolling. We are at the halfway mark, and I need to talk to you directly. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to the track.
So let's start Challenge 1, the data scan. Imagine looking at a massive, complex computer science data table on your exam. I'm giving you 60 seconds to scan the trend, the clock is ticking, look at the uncompressed bitmap size, look at the compressed size, what's the ratio? Now here is the terrifying part. What happens if you scan that data, you run the math, and suddenly you realize you've miscalculated the compressed size of an hour-long sound file? The timer's going down, 30 seconds, you're panicking, you think the entire question is a write-off, time's up. Do you just cross it all out and give up? Absolutely not.
Here is a direct, incredibly comforting insight straight from the examiner's mindset. Never, ever leave your calculations entirely in your head. Writing down your step-by-step process captures method marks. Even if you make a silly arithmetic error under pressure and your final file size is completely off, showing the examiner that you knew to multiply the resolution by the color depth will still earn you points. Method marks are your halo device in this F1 race. They will literally save your life when you crash on the final calculation. Always show you're working.
Now let's move to Section 4, Top Examiner Warnings. This is where we look at the exact places candidates bleed marks on the track.
Welcome to Challenge 2, Find the Flaw. I want you to look at a typical paragraph a student might write about sound compression. Let's read it together. To compress the sound file, we use an algorithm. This makes the file smaller by removing data so it downloads faster over the internet. Okay, where is the flaw? You have 60 seconds. Spot the sentence losing marks. Why does this answer fail? Think about what we discussed. 30 seconds. Look at the terminology. 10 seconds. Time. Straight from the principal examiner reports, that answer is flawed because it lacks specificity. It doesn't mention sample rate, it doesn't distinguish between lossy and lossless, and it doesn't apply to the context.
And that brings us perfectly to the 3 most common traps. 1. Using the wrong formula or algorithm for the context. 2. Forgetting boundary conditions in edge cases, like what happens to audio clarity when the sample rate drops too low. 3. Generic answers lacking specific question context. All right, Challenge 3, speed writing. You have exactly 30 seconds on the clock right now. I want you to mentally draft one perfect Peel paragraph explaining how to compress a high-res medical image without losing diagnostic detail. Go. Make your point. 20 seconds. State why lossless is mandatory. 10 seconds. Explain the risk of edge artifacts. 5, 4, 3, 2, 1. Pencils down. If you successfully navigated those 3 bullet points, you just wrote a top band answer.
Finally, let's bring it home with Act 5, the final system. Section 5, Evaluative Exam Strategy. This is how you reach the absolute top grade band and see that progress bar hit 100%.
To cross the finish line in first place, here is the complete computer science answering system. You must follow 3 rules. 1. Command word decoding. 2. Peel framework application. And 3. The time management matrix. Top candidates don't just calculate, they demonstrate evaluative thinking. They act as critics. They look at a compression scenario and consider multiple solutions. They analyze the severe trade-offs between saving storage space and losing crucial image quality. They acknowledge the limitations of an algorithm, and they meticulously justify their decisions with hard mathematical evidence.
So the crucial point is to use an evaluative matrix exactly like this one in your mind. Whenever you evaluate a compression algorithm, you have to weigh it against time complexity. How much processing speed will it take to compress and decompress? Weigh it against space complexity. What is the actual memory footprint? And consider the edge cases to ensure system stability. Now listen closely. Students who implement these computer science strategies see an average improvement of 2 whole grade boundaries. But that only happens if they practice consistently with our weekly videos.
Furthermore, when comparing compression techniques, you must explicitly state both the similarities and the differences using strong comparative connectives like whereas or conversely. This proves your analytical depth. And here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having the best pick crew in your corner.
You now have the ultimate cheat sheet, the insider's blueprint to mastering data compression for the Cambridge syllabus. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Turn these examiner warnings into your winning strategy. Apply the frameworks, show your workings, and dominate that 15%. I'll leave you with this final thought. As our world pushes towards incredibly massive data like 8K spatial video, will our current lossless compression algorithms be enough to handle the sheer volume, or are we inevitably racing toward a physical limit of how small data can actually get? Keep learning, keep pushing your limits, and I will see you on the podium next time.